Let's practice another example. Michaela Incorporated is a large company that manufactures dirt bike tires. Many professional dirt bike riders feel that when 1/8 of the tread on a tire has worn, the tire has exceeded its lifetime. Michaela needs to determine the average lifetime for their most popular line of dirt bike tires for advertisement purposes. So we are determining, or the company needs to determine the average lifetime, or the population mean lifetime. But we don't have access to the entire population. We're going to use a sample. So we have a sample of 100 tires, and we find that the mean lifetime is, that should say found, to be 170 miles. So we have a sample mean of 170. Assume the lifetime of the tires is normally distributed with an unknown population mean, that's what we're trying to estimate, and a population standard deviation of 30 miles. So we have the population standard deviation. These three things, 100, 170, and 30, are very important, and you should be able to pick those out of the words of the problem, as well as the confidence level. So in this problem, we are finding and interpreting a 95% confidence interval for the population mean lifetime of these tires. So we are trying to estimate the population mean lifetime by using the sample mean. We're going to find the margin of error of the confidence interval as well. So we're going to get started by noting the formula for a 95% confidence interval. And you have to know that the z-scores are negative 1.96 and positive 1.96. So the range goes from x bar minus 1.96 times sigma divided by the square root of n to x bar plus 1.96 times sigma divided by the square root of n. So the 1.96 is the z-score associated with a 95% confidence interval. So we're going to plug in our values of a sample mean, which came out to be 170 from the words of the problem. Sigma, the population standard deviation, was 30, and n, the sample size, was 100. So put those in, and now go to your calculator. So you can write 170 minus, and here we're going to put the z-score, 1.96, multiplied by 30, divided by the square root of 100. Okay, that can go on one line on the calculator. It gives us 164.12. And then the upper limit of the confidence interval, we take 170 plus 1.96 times 30 divided by the square root of 100. And that gives us the upper limit. So it is 164.12 to 175.88 miles. And that is our range of values. And that's an estimate for the population mean lifetime of these tires. So the purpose of finding the confidence interval is to estimate the population mean. The range we found will likely contain the population mean with 95% certainty. So that's the meaning of a 95% confidence interval. It means that we are 95% certain that the population mean lifetime falls within this range. So if we were to interpret that, we're going to say we are 95% confident that the true population mean lifetime of the dirt bike tires is from 164.12 to 175.88 miles. Okay, so we're going to always state how confident we are, and we're stating what we are estimating, the population mean lifetime of dirt bike tires, and then we state the value of the interval. If we have to find the margin of error, we're going to use the formula of upper limit minus the lower limit divided by 2. Upper limit is 175.88. We're going to subtract the lower limit, 164.12, and divide by 2. If we put this on our calculator in one step, we have to make sure that we wrap the numerator in parentheses. So I'm going to do that on the calculator. Our numerator, 175.88 minus 164.12 divided by 2. And 5.88 is our margin of error. 5.88 miles. So we could also state our confidence interval like this. 170 miles, which is our sample mean, plus or minus 5.88 miles. It's equivalent to saying the range 164.12 to 175.88. These say the same thing, just in different ways. They basically give a range of values around the sample mean 170. So you can go from here, from one to the other, by using the margin of error. Okay, so if you wanted to go from this notation, 164.12 to 175.88, to this notation, simply find the margin of error, take the sample mean, and plus or minus the margin of error. If you want to go from this notation backwards to this notation, simply take the sample mean, subtract 5.88, that's the lower limit, and then add 5.88, and that is the upper limit. We're going to do the same example. This is the same phrasing, except this time we're going to find and interpret a 90% confidence interval. So we're going to find our next answer with 90% confidence. And we're also going to find the margin of error there. So the only thing that changes here is the formula. For a 90% confidence interval, the formula changes so that the z-score is not 1.96, it is 1.65. Now, 1.65 is going to produce an interval that is actually shorter. And we're going to show that numerically. So if we plug in our 170, 30, and 100 in for the sample mean, population standard deviation, and sample size, we're going to get different values. So let's see. Going back to the calculator, we have 170 minus 1.65, that's our z-score for a 90% confidence interval, times 30 divided by the square root of 100. So our lower limit, oops, I put in square root of 10 by mistake. So let's fix that. Square root of 100. On the TI-84, you know when you're entering a value beneath the square root, because the square root line at the top will continue over the all the digits underneath it. So 165.05, and then if we do the upper limit, it is 170 plus 1.65 times 30 divided by the square root of 100, and that is 174.95. So 160.05 to 174.95 miles. We're talking about miles. So the purpose of finding this confidence interval is to estimate the population mean again. So what we found here is a confidence interval with 90% certainty, as opposed to the last one, which had 95% certainty. So we are 90% certain this range will contain the true population mean. So here's our interpretation. We are 90% confident that the true population mean lifetime of the dirt bike tires is from 165.05 to 174.95 miles. Now the margin of error, we're going to use that same formula as before. We're going to take the upper limit, 174.95, subtract the lower limit, 165.05 and divide by 2. That gives us a margin of error of 4.95 miles. 4.95 miles. So we can also state our confidence interval as, okay, so right now it's 165.05 to 174.95, but we can also state it with the sample mean 170 miles plus or minus our margin of error 4.95 miles. So we found two confidence intervals. We had the same sample mean, the same population standard deviation, and the same sample size, but we found a 95% confidence interval and then we found a 90% confidence interval. And if we look at the visual difference between the two, for a 95% confidence interval, remember that our range of values started at 164.12 and it went up to 175.88. So with 95% certainty, we were certain that our population mean was within this range with 95% certainty. And in a 90% confidence interval, we use the same sample mean, but this time our lower limit was 165.05 and the upper limit was 174.95. So this blue arrow, we had 90% certainty that our population mean was within the range from 165.05 to 174.95. So 95% confidence interval with the orange arrow and 90% confidence with the blue arrow. The greater the confidence level, the greater the range of values, which means you're going to have a longer arrow, a longer range. So increasing the confidence interval will increase the range, and it will increase the number of values that are possible for estimating the population mean. So decreasing the confidence interval will decrease the range and shorten the length of the arrow. So there will be less values possible for the population mean.